Hi and welcome. So this time around I got some more parts for that gentleman I made some parts for before that you've seen. He's got a lot of really interesting parts he wants made. So let's just dig right in here. The first part, pretty pedestrian, just a plate with some holes countersunk into it. He spec'd the countersink diameters, which was a little bit interesting. I don't have a specific countersinking bit, but drilled and tapped up here. I didn't think you'd want to see this, so I dimensioned it carefully. And he gave me tolerances on all the parts, which you see are fairly generous. Most of these numbers are 3 digits, so he wants them plus or minus 5 thousandths. A couple of them, like the hole diameters, plus or minus 10 thousandths. So pretty generous for the first part. And that one is done already. I figured I'd do that one off camera. The next part is actually a pair of parts. He wants 2 of these, and they're made out of Delrin. And this is actually, got it upside down, this is actually the second iteration. The first time, he wanted the thickness, here it shows 0.125, I wanted 1/8 inch essentially, actually 0.120, just under 1/8 of an inch. But then he called me back and said, you know, 1/4 inch would be fine. So I bought some 1/4 inch Delrin here, and we're just going to work it out. We're going to build these 2 pieces out of the end, which should speed things up. And I'll show you my approach to that. Making the, I mean, there's a pretty simple part, but making these is going to be kind of interesting to get the work holding down. The way I first thought about doing it was, you know, cutting these sides, dimensioning the stock like I normally do, and then coming back and putting it on a mini pallet, and then, you know, running a gauge and getting it all lined up on the mini pallet, hold it on the mini pallet and do it that way. But I've got another idea that I want to try for this, and it's an interesting approach, so I'm going to give it a shot. The next 2 parts, a bit challenging. This one is double V blocks, and it's going to be particularly challenging to get into these corners here and get any kind of small radius, because you can see from the profile here that there's a raised portion, and it's a different thickness V block that he's got spec'd out. So that one's out of aluminum. Here's the raw materials for that. The next one also is challenging. It is this tiny little square chunk of aluminum here, and he's got these really unusual angles. This one's not a compound angle. This one is just a single angle where I will use, I am guessing I am going to use a sine bar to set that angle. This one's a compound angle, so the part needs to be rotated and tilted. Maybe you can see from the side here, he's got a couple other drawings that show the parts here. So those are going to be interesting. Maybe 2 sine bars, or I'm not quite sure yet how to do those. He's got positioning drawings he sent me after. So first, let's head over and do the Delrin parts and see how they work out. First up, we're going to dimension the stock. I've cut off a much bigger piece than I need so that I can use the rest of the material to hold the little pieces. So what I'm going to do is I'm going to make little half-inch pieces, 1 on each end here, and then I will you know, cut them off and get them down to final dimension after, because it's going to be, it'd be a big challenge to hold those tiny little parts, and the mini pallet would make short work of it, but I thought this might be an interesting approach where I could do it all at once. So this is about 2.52, and I need it to be 2.12, so I need to square this up. So what I've done is I've biased the milling cutter to the outside this way, so that the cutter is essentially coming in perpendicular, pushing into the fixed jaw. It just barely overlaps in the back, and we're going to take a little cut off here. I'm going to try 120 thousandths. This stuff's really soft, but it's not well supported up here, so we'll give it a shot and see what happens. That's looking good so far. As with a lot of plastics, I don't know if you can see it here. Let's see if we can focus. Focus right here. So you can see that tiny little tear out on the end. But fortunately, I've got to round these ends over anyways, so that will not be a problem. With plastics, you can get away with pretty deep cuts. This is 200 thousandths. I am using an aluminum cutting end mill, so it's very sharp and it's got a non-stick coating on it. It seems to work pretty well with Delrin, so that's what I'm doing. The only problem is with such a large cut, I do risk tear out on the end, so I'm going to manually walk that through, and it'll probably still chip off a bit. So now I've got the top and the bottom dimension, this thickness here between my thumb and forefinger, pointer finger. That's the correct dimension. I'm within 1/2 thousandth. And being plastic, change temperature a little bit, and that'll be all over the place. So he's got pretty loose specs for that, so it's not a problem. I can be plus or minus 10 thousandths, and we're all good. So now I've got a square. Since I've got these sides parallel, I can clamp these in the jaw, and I can just square off both these two sides, and I can make one part, flip it over, and do the other part. So that's what I'm going to do. By the way, not worth a whole quick tool review all in itself, so I'll just show you here. I ordered these from Grizzly, and you order these in different sizes. These are 16 millimeter for my 5/8 slots, and you can even use coolant and it'll still be able to drain through, but the chips will stay on top. Just helps to keep chips, especially right around the vise where this thing doesn't really meet up, so I always get chips in there, kind of a pain in the butt. These things you can just slide right in. If you want to take them out, they come out really easily. They fit really well. Just inexpensive extrusions. They were $30 or so, as I recall, for the set of 6, both sides. So a handy little tool to have. So now I just need to square the two sides to no particular dimension, because I'm not going to get the final thickness until I cut the parts off, one from each side, and then get that to final dimensions. So what I'm going to do here is I'm just going to run an end mill right across it real quick, just make sure I clean up the whole thing. So that's a 1. That makes this side perpendicular to these other two. And now we'll just flip this around and do the other side. Got to make sure not to tighten the vise too much or I'm going to cup it. And we're done. All right, one more thing before I go here. If you think about the way end mills are made, if you need a really sharp end mill, you don't want to use a coated end mill at all. You want to use just a plain carbide. And the reason is pretty straightforward. When they're making an end mill, they grind and sharpen it in the first process, whether it's carbide or high-speed steel. Then they send it off for coating. Well, the coating is material that's thick, you know, some measurable thickness on top of the already sharpened part. So if you're looking for the finest edge, that coating is going to make that edge a little bit more rounded off than it was when it started. So just think about that. If you need a really sharp end mill, you need a plain uncoated end mill. These days, I don't think it matters whether it's high-speed steel or carbide, because I think they can make carbide every bit as sharp these days. So next up, I needed to massage the drawing. Because of the way this drawing's spec'd, he gave a radius of 90 thousandths, which means that this diameter is twice that, or 0.180, 180 thousandths. So the center line, he gave the edge. So this is 180 thousandths wide, 90 thousandths to the middle. So add 90 thousandths to 160, 0.160, and you get a 1/4 inch is the center line here. So you got to be careful. And then he gave the height to the bottom of the hole, but I don't have a 180 thousandths end mill, so I can't do this with an end mill by itself. So what I'm going to do is use a drill bit and drill up. The 180 thousandths turns out it's a number 15 drill bit. So I'm going to drill here and here. I had to subtract 90 thousandths off the top, add 90 thousandths to the bottom to find those two center points, 1/4 inch in. So I'm going to find my corner here and just going to come and do these two spots real quick. By the way, once I've found my X and Y zeros, I always like to do a sanity check and put my drill bit or whatever it is over 0, 0 just to make sure that I didn't screw up and forget to, you know, move the DRO, you know, move the whole table over 100 thousandths in each direction to compensate, or when you're doing a middle, you don't do that. So just to make sure I didn't do a stupid. So all three of these holes are going to be on the X dimension. They're going to be over a 1/4 inch, which is really handy because that means I don't need to move anything around. So we can leave the X on a 1/4 inch. I've got to make sure that my parallels are all the way back because this is just barely going to miss them. It's 160 thousandths off the bottom, but actually a 1/4 when I compensate for. So there's my 1/4. So I've got to drill a couple holes here. Boy, I hope I don't have this extended over too far. I wanted it off the edge so that I could easily indicate off of it, but this might be a little bit extreme. Oh, let's see. We will see. We'll drill slowly. First hole. Okay, that worked out pretty well. Next hole is going up 0.490. What I'm going to do is when I come back is I'm going to take an 1/8 inch end mill and clean up the gap in between them. The third hole is up 1.38. Perfect. Now, since this one's right on the money, when I take this part out and I flip it around, and it really doesn't matter which way I flip it around, at least I can't think of a reason why it would matter, I will be right on the 1.38 for the other side, so we'll just start there. Okay, down to 0.490. Double check my numbers, 0.490. Okay, finally 0.250. Now, I don't have my jaws very tight on purpose because I am a bit concerned about deforming the plastic. Normally you don't want to put any side forces on a drill chuck, but I think with plastic I can get away with this. So it's plus or minus 28 thousandths, and we want to run up to the other side. Okay, there's my first slot, just need to deburr it. For this next hole, I'm going to take smaller bites, so I'm not going to try and cut it all at once. That seems to be working a lot better. Doing a double check to make sure a .180 drill bit slides back and forth freely. I still need to deburr these edges, but now I just need to flip this part around and do it again. Exactly the same bit. Alrighty, so again, using an end mill in a drill chuck is not the ideal solution, but this is plastic and I was taking very small bites with a very small end mill, so I did that mostly to give you guys visibility of seeing what's going on, so hopefully you could see. So now I've got both sides of this done, one part on each side. So now I just need to cut these off, and I need to come back with an end mill and dimension this to final size. And we'll be good. We'll have two parts completed after I deburr them. Now to speed things up, I've got both pieces in there together so that I can get their final dimension. I left a little bit sticking over the edge here so I get a mic on it. We'll take a measurement. It needs almost 200 thousandths off, so I'm taking about 100 thousandths, I think, a little over. So we should need at least one more pass. I gotta tell you, this Delrin is wonderful stuff to work with. It just cuts like butter. It doesn't even chip out anywhere near as badly as acrylic. By the way, if this were acrylic and I wanted to not get chip out, what I would do is I'd bring the end mill down this side where the cutter head is rotating into the work, and I wouldn't cut all the way through the part. Then I'd come back on this side and I'd do the same thing for the remainder of the material on this side. That way it would be constantly pushing the cutting edge into the work itself. Hopefully that made some sense. Heck, that might have only been like 50 thousandths, just based on these slots should be exposed. If you can see it right in there, those slots should be exposed when I'm finally done. I only left a few thousandths over. I should have gone a little bit farther, would have made it easier, but anyways, I didn't. So once this is done come through, I'm gonna take a real quick measure, and I'm gonna do a couple more passes. All right, so there's the two parts I did to back to back within spec. I just need to clean up the inside of these slots a little bit with a sharp tool. And we're done with this set of parts. I thought these were interesting, and I thought I found a pretty efficient way to do it. If anyone has any better ways to do it, love to hear about it, so next time I can be better. By the way, love the new slot covers. Here's the parts, and they turned out really well. I just need to clean up the insides a little bit with a sharp deburring tool. Slot covers made it a lot easier to clean up all the swarf that's close in here that's not protected by this guy normally. Like them so far. Grizzly, 30 bucks. Thanks for watching. Hope to see you next time.